So before discussing Faraday's second law, we can discuss, or actually what is my suggestion, simply go to previous lectures, especially try to find out equivalent weight. We have carried out this calculation, molecular weight, equivalent weight, what is equivalent weight of substance. Just revise that lecture and then start out this video once again. The reason is that the base of this Faraday's second law is on equivalent weight of substance. So what is equivalent weight of substance? That go from that lecture, find out and come again. So you are aware of equivalent weight of substance, and then only we have to observe this video, because otherwise there will be of no use. So let us start out. According to Faraday's second law, if same quantity of electricity is passed through different electrolyte, then weight of substance deposited is directly proportional to their equivalent weight. I am revising the law. If same quantity of electricity is passed through different electrolytes, then weight of substance deposited is directly proportional to their equivalent weights. But Faraday is not using word as equivalent weight. They are using their chemical equivalent. It's a bit confusing. Say electrochemical equivalent, that we have discussed Z, and chemical equivalent, that means their equivalent weight of the substance. So instead of using chemical equivalent word, we are using here equivalent weight of substance. Let us illustrate this. I am having these two cells. These two cells are connected in series. This is first electrode, so this is connected to positive terminal. This is battery. This side is positive, this side is negative. Key. Then in order to detect, we are using here milliammeter and we are connecting. So this is the obvious that when we are using here solution, the circuit is completed. So this is now cathode. This is anode. So in this circuit, this is anode and this is cathode. I am connecting out these cells in series. The meaning is that these cells are connected in series means the same quantity of electricity is flowing through it. The moment I am closing key, that means circuit starts working, and opening, the same quantity, that time is same and I is also same. Suppose this solution contains copper sulfate and this contains silver nitrate, and we are carrying out electrolysis. Then weight of deposited on cathode of copper and weight of deposited on cathode of silver, that will be the directly proportional to their equivalent weight. That means weight of copper deposited should be directly proportional to what we can say equivalent weight of copper. Same way, weight of silver deposited, that will be directly proportional to equivalent weight of silver. So combiningly, I can say that weight of copper deposited upon weight of silver deposited, that is equal to equivalent weight of copper upon equivalent weight of silver. Because here constant is there, here also constant is there. I am eliminating that simply by making this law. So weight of substance deposited is directly proportional to equivalent weight of substance. So this is Faraday's second law. But for this purpose, you are aware that same quantity of electricity must pass. That means my I into T, this should be constant. So in short, I can write W is equal to Z I T. But if I am considering for second law, we have considered that I into T as constant. So if I and T is constant, then I can say that W is directly proportional to Z. Just we have considered W, when IT is constant, W is directly proportional to equivalent weight of substance. And when IT is constant, W is directly proportional to Z. That means I can say W is directly proportional to Z and W is directly proportional to E. That means there is something connection between Z and E. So I can consider equivalent weight of substance is directly proportional to Z of the substance. I have to remove this proportionality sign, so I can write down that equivalent weight of substance should be some constant into Z. That means I can find out value of this constant F. F stands for Faraday. This is constant of honored name of for Faraday. So F equal to E by Z. Faraday carried out series of experiment where E is known and Z is also known, and ultimately able to fix value that is equal to 96500 coulombs. In some book this value is given as 96520 coulomb, and in some book there are 20 means writing out 2 zeros. So anyway, you can go here, whatever the convenient value you can keep in mind. I can keep this way 96500, or simply keep in mind 20. If answer is going by this answer correctly, this figure correctly, you can use this, because certain CBSE boards they are using this 20 figure. So CBSE books and state board books they are using this figure. So this is a bit confusing, but anyway 20. That means we can go safeguard. So this value is determined. So I can give relationship that E equal to 96500 into Z. So this way we can find out the relationship between E and Z. Or I can say that Z equal to E by 96500. That is also right. That is E by F. And I can substitute this figure in this formula. So I can combine two laws now. The first law of Faraday states that weight of substance deposited is directly proportional to quantity of current passed. Second law states weight of substance is directly proportional to equivalent weight if same quantity of current is passed. That means I can combine these two laws and I can state W is equal to, I am replacing the value of Z by E by this. So W is equal to E by 96500 into I into T, or W is equal to into Q. That means 96500 is important figure over here. Simply one can say 96500 is charge of 1 mole of electron. I am revising, this is charge of 1 mole of electron. So 1 mole of electrons, 1 mole of electrons, that corresponds to 96500 coulomb. So 1 Faraday is charged on 1 mole of electron. So we are going on electronic level now, and from this figure we can find out the charge on 1 mole of electron, that is 6.022. According to modern figure we have to take this, otherwise we are taking 0.23. So here 6.022 into 10 raised to 23 electrons. They will possess charge as 96500 coulomb. And therefore we can find out charge on 1 electron. So what is the charge on 1 electron? So this way we can go 96500 upon 6.022 into 10 raised to 23 multiply by 1. So if you are carrying out this calculation, you will get answer, that is the charge on single. So this answer comes as 16024.57 into 10 raised to minus 23. I don't want this, so I have to write down this way, 1602457 into 10 raised to minus 23. I have to shift this decimal till here, that means 1, 2, 3, 4. So I have to shift this decimal 4 places. So I can write down this way, into 10 to the power of, now minus 23, or we have shifted 4 places, so into 4. So that will get me the total of minus 19. So we are having answer as 1.6. I am ignoring now, into 10 raised to minus 19 coulomb. So this is a charge on 1 electron. So this way we can find out charge on 1 electron in this basis. No doubt another calculations are there, that oil drop experiment is there. From that oil drop experiment also we can verify this charge on electron. This is the Faraday's first law and Faraday's second law. Now you are aware, by combination also we can find out the variety of answers. Let us take out one more sum. Find out weight of substance deposited on cathode when 2 moles of electrons are passed through aqueous copper sulfate solution. Equivalent weight of copper is 31.77. On basis of this data, we have to find out weight of substance deposited on cathode. Now it is obvious that we have 2 moles of electron, whereas equivalent weight of substance given, that is 31.77. So that is in terms of gram. So I have to convert this in terms of kilogram. So into 10 raised to minus 3 kg. This is my equivalent weight we have determined. Now we have 2 moles of electron. Keep in mind this law, that 1 mole of electrons will correspond to 1 equivalent weight of the substance. Therefore, here 2 moles are there. So they will deposit 2 into equivalent weight of the substance. So that will be equal to 2 into 31.77 into 10 raised to minus 3 kg. So that will be equal to atomic weight of substance. So into 10 raised to minus 3 kg. So weight of substance deposited will be this.